In graph 12.14, we gave some intuition for why the profit function has to be convex in output prices, and how this then gives some intuition for the first part of Hotelling's lemma. In the animation here, we'll do the same for the slice of the profit function that varies with wages rather than prices, and then give intuition for the second part of Hotelling's lemma. We'll assume throughout an output price of PA, and we'll start with an initial wage of WA. At that initial wage, we have some initial profit maximizing production plan, like plan A in panel A of graph 12.14. And at that profit maximizing production plan, we attain a particular profit, which is given here as the vertical component of the point A prime. We can then again think about what the slice of this profit function would look like if we had a naive producer who always produces production plan A no matter what happens to the wage. Profit is equal to price times output minus wage times labor. And if we hold the production plan fixed at XA and LA, and we hold the output price fixed at PA, we get a profit function of profit equal to PA times XA minus W times LA. In other words, we get a linear function with a vertical intercept of PA times XA and a slope of minus LA. If the wage then increases from WA to WB, and the producer continues to produce at production plan A, profit will fall along this blue naive profit function. He will therefore attain a profit that's indicated here as pi double prime. A profit maximizing producer, however, will not stick with the production plan A, but will rather shift to a different production plan that can only result in more profit, given that she could always do what the naive producer does, but she can adjust, and so she'll end up doing better. The same will be true for any change in the wage rate, because the profit maximizing producer will always do better than the naive producer who's simply producing production plan A, except for at the wage rate WA, where the production plan A happens to be exactly the right profit maximizing production plan. The further the wage deviates from WA, the better the profit maximizing producer will do relative to the naive producer who's always using production plan A. We therefore get a profit function that is tangent to the naive profit function for the producer who always uses production plan A at A prime, but will diverge from it as we move away from A prime. When the wage falls, for instance, from WA to WC, the naive producer continues to stick with production plan A, whereas the profit maximizing producer will increase production and increase profit. We can therefore see that this slice of the profit function, where we vary the wage rather than the price, also has a convex shape, although now it is downward sloping rather than upward sloping as it was when we varied the price in graph 12.14. We can also now see the second part of Hotelling's lemma emerging. The second part of Hotelling's lemma says that the partial derivative of the profit function with respect to the wage is equal to minus the labor demand function. Here, at point A prime, the derivative of the profit function with respect to the wage is equal to minus LA, which is the labor that the firm demands when the wage is equal to WA. The blue line here is not the only possible naive profit function. It's just the one that applies to the producer who always insists on producing production plan A. We could pick some other production plan on the production frontier and associate a different naive profit function with it. That profit function will also be tangent to the actual profit function, but at a different wage, the wage where that particular production plan would in fact be the profit maximizing production plan. Thus, this slice of the profit function is again the upper envelope of lots of naive profit functions, and at each tangency we get a similar relationship as the one we've graphed here. We can then see Hotelling's lemma that the partial derivative of the profit function with respect to wage is equal to minus the labor demand function emerge from the picture.